Have you ever wondered how robots manage to perform complex tasks, navigating dynamic environments, and making decisions that seem almost human? It turns out, how a robot thinks and decides its next action is crucial, and it largely comes down to its control architecture. When designing a robot system, choosing between deliberative and reactive control paradigms is fundamental because it directly impacts the robot's ability to operate effectively and safely in its intended environment. Deliberative control, often described as a top-down approach, involves extensive planning and world modeling before action, while reactive control, a bottom-up strategy, prioritizes immediate responses to sensory input without complex planning. The best choice depends entirely on the specific application, considering factors like environmental predictability, computational resources, and response time requirements. The core mechanism differentiating these two lies in their decision-making processes. Deliberative control relies on an internal representation of the world, generating a detailed plan of action through algorithms like a star search or rapidly exploring random trees before executing any movement. This allows for optimal, globally coherent behaviors but can be slow and computationally intensive. In contrast, reactive control directly maps sensory inputs to actions, bypassing explicit planning. It uses simple rules or behaviors like obstacle avoidance to ensure quick, robust responses to sudden changes, but it can lack foresight and struggle with long-term goals. To decide which approach is right for your robot, consider the operational context. If your robot operates in a static, predictable environment where optimal path planning is paramount, such as an assembly line, a deliberative system might be ideal. Here, the time taken for planning is offset by the precision and efficiency of the executed plan. However, for robots in highly dynamic and unpredictable settings, like an autonomous vacuum cleaner navigating a busy living room, a purely reactive system offers the necessary speed and adaptability to avoid collisions and keep moving. Real-world applications often benefit from a hybrid approach, combining the goal-oriented planning of deliberative systems with the real-time responsiveness of reactive ones. A key insight into advanced robotics is that neither paradigm is inherently superior. Instead, their strengths are often complementary. Many successful robotic systems today employ a hierarchical or hybrid architecture. This often involves a high-level deliberative planner setting long-term goals, such as reaching a distant landmark, while a low-level reactive controller handles immediate execution and obstacle avoidance along the planned path. This blend provides both intelligent foresight and robust, real-time adaptation to unforeseen circumstances, achieving a balance between efficiency and safety that pure approaches often cannot. Ultimately, the decision between deliberative and reactive robot control is a strategic one, balancing the need for intelligent, goal-oriented behavior with the imperative for quick, safe responses to an ever-changing world. Understanding these fundamental paradigms allows engineers to design robust, effective robotic systems that are perfectly tailored to their operational challenges, whether they are precisely assembling components or dynamically exploring unknown terrain.
If you love robotics, like, subscribe, and keep building with us.